Analysis of variance is a way of using a hypothesis test based on sample variances to assess differences in population means. To illustrate the basic idea, consider histograms of samples from 3 populations. If the histograms are widely separated relative to the width of each histogram, then it's likely that the population means of the populations from which these samples are drawn are different. And if the histograms show a lot of overlap, then it's likely that the samples were drawn from populations with the same mean. So by comparing the variance between samples with the variance within samples, it's possible to make inferences about the population means. The test statistic in an analysis of variance hypothesis test is based on the ratio of the variance between sample means to the variance within the samples. If this ratio is small, then it's likely that the population means are all the same, and if this ratio is big, then the means of the populations from which the samples were drawn are probably not all the same. To see how this works out in a specific example, here are samples drawn from 5 populations. The samples are identified by a categorical variable with values A, B, C, D, and E, and the values within each sample are values of a quantitative variable. Here are histograms of those samples. The null hypothesis is that the population means of the populations from which these samples were drawn are all the same, and the alternative hypothesis is that the means are not all the same. This input uses the ANOVA function to do the analysis of variance hypothesis test for this data. ANOVA stands for Analysis of Variance. The first argument in this input converts the data into the form needed by the ANOVA function. The result includes a table called an analysis of variance table and a table that gives the means of the samples and the overall mean, sometimes called the grand mean of all of the data. The analysis of variance table includes the F ratio, which is the test statistic of the analysis of variance hypothesis test, and the p-value of the hypothesis test. The p-value in this example is about 1.4%, so with significance level of 5%, the conclusion is to reject the null hypothesis and conclude that the population means are not all the same. As already noted, the F ratio test statistic is based on the ratio of the variance between sample means to the sum of the variances within the samples. The F ratio depends on the list of sample means, which is given by this input, the size n of each sample, and the number of samples k. In this example, the size of each sample is 10, and there are 5 samples. The F ratio is n times k times the variance of the sample means divided by the sum of the variances of the individual samples. The sampling distribution of the F ratio is a distribution called the F ratio distribution, which has 2 parameters, the degrees of freedom k-1 of the numerator and the degrees of freedom k times n-1 of the denominator. The p-value can be computed using the cumulative density function CDF of that distribution and corresponds to the area in the tail of that distribution beyond the value of the test statistic. This is the p-value shown in the analysis of variance table. The analysis of variance table also shows intermediate results in the calculation of the F ratio. Instead of showing variances, however, the analysis of variance table traditionally shows the sums of squares that come up in calculating variances. The variance of a list X is defined as 1 over n-1, where n is the length of the list, multiplied by the sum of the squared differences between the values in the list and the mean. The analysis of variance table shows the sums of squares without the factor of 1 over n-1. The column labeled DF shows degrees of freedom for the numerator, the denominator, and the total. The sum of squares column shows the sums of squares that come up in calculating variances, and the mean squares column is the sum of squares divided by degrees of freedom for each row. The row labeled model corresponds to the variance between sample means, and the row labeled error corresponds to the sum of the variances within each sample. The ratio of the 2 mean sums of squares is the F ratio. The analysis of variance test described in this section is called a one-way analysis of variance because there is one categorical variable in the data. There are many variations of this calculation, including two-way analysis of variance, where the data involves 2 categorical variables, or three-way analysis of variance, and many other generalizations of the basic idea of using variance to compare population means.